Ternyata indah di mata dunia. Hidup harmoni berbilang bangsa, wajah riang manis senyuman, sejahtera sealun senada sejiwa. Pantai pasir putih, lautan biru, desiran ombak dihembus bayu, hutan hijau malam berseri, bunga-bungaan harum mekar menawan hati. Malaysia indah di hati jiwa kita semua. It's a truly Asia, Malaysia menawangi kehidupan bahagia. Melawat Malaysia, kita seni budaya dan bangsa. Visit truly Asia, Malaysia, segala bermula di sini, di Malaysia.
Andaikan kau buat tak bagi Malaysia. Visit truly Asia, selamat datang ke Malaysia.
Excellencies, honorable guests, and participants, welcome to the opening ceremony of the International Exhibition and Conference on Industrial Revolution 4.0. For this year event, due to the pandemic condition, we will not have the exhibition, and we are organizing this event with 3 conferences. International Conference on Advances in Mechanical, Materials, and Manufacturing Engineering, International Conference on Advances in Computer Science, Electrical and Electronic Engineering, International Conference on Advances in Architecture, Sustainable Construction and Built Environment. We are proudly present this significant academic conference with the grand theme of Together We Embrace Industrial Revolution 4.0. This academic conference is jointly organized by Mahsa University and Sigma Research and Consulting, SRC Group in Malaysia and the Netherlands. Ladies and gentlemen, this conference is one-day program of plenary speech, technical seminar, and parallel presentations by remarkable speakers and significant authors across continents, academics, scientists, and practitioners from various specializations related to architectural, civil engineering, computer science, electrical, electronic, and mechanical engineering to share their inter, trans, or multidisciplinary research findings and professional experiences. I am Dr. Sattar Mamian, your Master of Ceremony of this event. Ladies and gentlemen, I'm pleased to welcome with honors Yang Berbahagia, Professor Dr. Ikram Shah bin Ismail, Vice Chancellor of Mahsa University, Professor Dr. Sri Kumar Chakravarti, Director of Research, Innovation and Postgraduate Studies, and Dr. Iman Farshi, Conference Chairman and Dean of Faculty of Engineering and Built Environment, Mahsa University. And today, we are grateful to have the honorable plenary speakers, Professor Afandi, Universitas Negari Malang, Indonesia, and Dr. Andrea Galli, Politecnico di Milano, Italy. Respected session chairs, for session A, Dr. Iman Farshchi, session B, Dr. Noor Azima, session C, Associate Professor Dr. Abdurrahim Sadiq Bachater. We are also pleased to have the respected speaker for technical seminar, Dr. Amirreza Shaiganpour, Istituto Italiano di Tecnologia, Italy. Fellow paper presenters, participants, ladies and gentlemen, on behalf of the organizing committee, let me extend a very warm welcome to each and every one of you to the virtual 2021 IESIR Academic Conference. In a very glance review, let me brief our virtual conference itineraries. For today, 1st December 2021, conferences will start with an opening remarks by conference chairman, Director of Research, Innovation and Postgraduate Studies, and official opening remarks by Vice Chancellor of Massa University. Plenary speech by Professor Effendi and Dr. Andrea Galli. Please be informed on the parallel session for technical paper presentation of session A, B, and C. This will be held from 3 p.m. until 4:30 p.m. Malaysian time. Before we proceed with technical seminar by Dr. Amirreza Shaiganpour from 4:30 p.m. until 5:30 p.m. Malaysian time. We will continue back with our parallel session from 5:30 p.m. until 6:30 p.m. Malaysian time. We got in total about 6 to 7 paper presentation from each session. Please arrange your time accordingly for meal and pray in between of the event. Please stay tuned with us for closing at later after 6:30 p.m. Malaysian time. Best presentation award announcement as well as brief talk about publication will be delivered during the closing ceremony. Ladies and gentlemen, now without further ado, we would like to invite our respected conference chairman, Dr. Iman Farshchi, for delivering his conference welcoming speech. Please welcome.
Good afternoon, everyone, or good day to everyone, because we have many international lecturers and participants for this conference. Thank you so much, Dr. Sattar, for warm speech and welcoming for our conference. Welcome and good day to everyone. Hope you all stay safe for today. So today we have one of our greatest events. Today is our third conference for Faculty of Engineering and Built Environment, Massa Universities. So we're really proud that we have the third conference. It shows that how our faculty is and our research members are thirsty to do more research and learn more in the theme of our faculty, which is now we focus on IR 4.0 and green technology. Today event, we are collaborating with the Sigma Research Company, which is amazingly helping us to conduct this conference. We really appreciate Dr. Sattar for his great involvement for this conference. So today conference theme will be International Exhibition and Conference on Industry Revolution 4.0, which we have 4 main areas, which is architecture, sustainable construction and built environment, computer science, electrical and electronic engineering, mechanical material and manufacturing engineering. So this is exactly, it is the theme of our faculty this year, which we more focus on all this new IR 4.0 and green technology. And we are really want all our students and researchers involved with that. Today also, I really appreciate our great Vice Chancellor, Professor Dr. Ikram Shah, and also distinguished Director of Research, Innovation and Postgraduate Study, Professor Dr. Seri Kumar, to join us for opening speech today. We have great speakers today, which is from Professor Effendi from Universitas Negeri Malang, Indonesia, which is one of the pioneers of engineering in Indonesia. We have Professor Andrea Galli from Politecnico di Milano, Italy, one of the best universities, especially in case of civil engineering and all engineering part. And also we have great speakers, Dr. Amirreza Shaiganpour from one of the best research institute in Italy. And this make our event more interesting, which have more lots of speakers from internationally. And It helped us to have a great international sharing session, which I'm pretty sure at the end of the day, all the participants can have lots of knowledge and gain extra knowledge related to current industry demand. So I won't take too much time. I know that everyone really excited to hear the speech from our great speakers. So thank you so much once again to join our event. So I hope that everyone to enjoy today event and gain lots of knowledge. And I'm looking forward to see all of you until the closing ceremony. Thank you so much and I appreciate it. Thank you, Dr. Sattar. So I will pass the platform to you. Thank you.
Thank you, Dr. Imam Farshi, for the notable welcoming message. Thank you so much. At this moment, I would like to invite Professor Dr. Sri Kumar Chakravarti, Director of Research, Innovation, and Postgraduate Studies.
Thank you so much, Dr. Sata, and thank you, Dr. Iman, for inviting me today for this event. And this is a conference which has 4 different streams. And all you participants are lucky because you are attending a conference, and conferences are dying even these days. Until last year, we had conferences that were face-to-face. The past 2 years, conferences have been online. And in a few months onwards, the talk that you're going to talk today, IR 4.0, is going to take over. So you will never have conferences again. It will be robots that actually give us talks. And you wouldn't even have to look at a TV screen. Your glasses would have monitors, and you can actually look at a conference or see the PowerPoint in your glasses. Or you could hear the talk while you're driving to work. Well, talking about driving to work, because of all this IR 4.0, the World Economic Forum has said that 30 to 50% of full-time staff would lose their jobs, and robots would replace 800 million workers. Well, this sounds depressing, but this doesn't mean we're all going to lose jobs. It would be a change in the workforce, and the displaced employees would actually be able to work on different, more challenging and beneficial roles with the right skills. That's what we talk about reskilling and upskilling and so on. So, ladies and gentlemen, today's conference, I understand, has a very interesting program and about recent trends in IR 4.0. So, I would like to welcome all of you, national, international, and local participants, and I hope you have a wonderful time during the sessions. And I also like to extend my heartiest congratulations to Dr. Iman and his wonderful team for churning out yet another wonderful conference at a time when everybody is packed with so many various different challenges, and you are bringing out conferences with the right theme at the right moment, and that is the spirit. And best wishes again. Thank you very much and have a nice day.
Thank you, Prof. Sri Kumar, for the notable welcoming message. Now we are going to officially open this event by remarkable speech of young Barbagia Professor Dr. Ikram Shah bin Ismail, Vice Chancellor of Mahsa University. Datu is muted. Could you please unmute?
Okay. How's that?
Great. Thank you. Please.
Welcome to the International Exhibition and Conference on Industrial Revolution 4.0, or the IECIR. This conference is organized by the Faculty of Engineering and Built Environment. The IECIR 2021 aims to bring together academicians, researchers, and industrial professionals from all over the world to share their experiences in the field of engineering and technology. It provides a platform for researchers, educators, and students to present and discuss the most recent innovations, practical challenges, and solutions adopted in their fields. This conference is conducted entirely online in view of the raging pandemic, but I hope this will not deter any fruitful discussion that will follow. The theme for this conference, as mentioned before, is Together We Embrace the Industrial Revolution 4.0. This international conference is actually a mega conference consisting of 3 different conferences covering 3 different aspects of industrial revolution. 4.0. These conferences are, as mentioned before, Advances in Architecture, Sustainable Construction and Built Environment, the ASCB 21. This conference strives to impart new frontiers of knowledge in current scientific evidence-based information and technical skills in various fields of built environment, such as civil engineering, architecture, construction management, and quantity surveying from the masters in the field. The dean himself is the chairman for this organizing committee for this conference. The second conference is the Advances in Mechanical, Materials, and Manufacturing Engineering, the AMMM 21. Now, this conference will provide a platform for researchers, academicians, and practitioners to share the knowledge of the new findings and discoveries, especially in three major fields, which are mechanical, manufacturing, and materials engineering. This conference is chaired by Dr. Muhammad Sabirin Rahmat. The third conference is the Advances in Computer Science, Electrical and Electronic Engineering, CEEE 21. This conference will provide a platform for researchers, academicians, and practitioners to share knowledge of the new findings and discoveries, especially in three major fields, which are computer science, electrical, and electronic engineering. Chairperson for this is technologist Nur Azliza Ahmad. The ongoing digital revolution is a combination of Industry 4.0 and the Internet of Things, which offers probably the greatest opportunity for our economy to move towards a brighter future. Today, all kinds of devices, from autonomous lawn mowers to thermostats or lamps to cars or even simple kitchen appliances, are capable of contacting other gadgets or data sources via the Internet, which was unimaginable only a few years ago, but is very normal today. Today, it is time to make industrial productions more agile, intelligent, and efficient. This is done by endowing machines with the ability to develop themselves in a diverse range of forms and configurations. These machines now have the capability of communicating with other systems or other machines via the cloud. Finally, I would like to congratulate the organizing committee under the able leadership of Dr. Iman, Dean of Faculty of Engineering and Built Environment, Dr. Muhammad Sabin Rahmat, and technologist Nur Azaliza Ahmad. And I wish you all a fruitful discussion and a successful conference. Thank you.
Thank you so much, Prof. Datu, for the fruitful and notable welcoming message. Ladies and gentlemen, our next important agenda of plenary session has come to the turn. We will have two invited speakers for plenary session. We will start with first plenary speech by Professor Dr. Afendi, followed by the second plenary speech by Dr. Andrea Galli. In due to that, let me introduce our first distinguished plenary speaker, Professor Dr. Afendi. Prof. Afendi received a PhD from Kumamoto University, Japan. He is a full professor who currently working as a senior researcher at the Electrical Engineering Department, Universitas Negari Malang, Indonesia. He is also currently charging as a chair of the Power and Energy Society chapter, Institute of Electrical and Electronics Engineers, IEEE. He is now a senior member of the IEEE and more scientific societies. Now, without further ado, we proudly bring to you our honorable, respected plenary speaker, Professor Dr. A.N. Afendi, to deliver for his plenary speech. Please welcome Prof. Afendi. 20 minutes time is all yours.
Thank you, Satar. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, first of all, I would like to deliver my gratitude for Maksa University, addressing for Professor Ikram, Professor Sri Kumar, and Professor Iman. Thank you for inviting me virtually to come to this good flagship conference, ICCIR. So I also thanks to all committee members to bring this conference being successful for the next series, and also equality for all of the participants and keynote speaker. Thank you very much for joining this meeting and become a part of the IECIR. I would like to show my research work focused on the presentation. This is my views for the meeting today concerned on the dynamic power transaction based on the open transmission use chart. Especially as we know that electric energy now become one of the needing in our activity, not only for support humanity, but also for daily activity. One of the important thing about the inside of the electrical system during the delivery energy from the northern sea to the some area of the demand, it is very important how the power station become integrated system for supporting all of the energy using in our daily activity. This is the commonly for typical for the power system starter. There are any generation system. After that, also cover for the transmission system, commonly with distribution system to distributed energy until it's coming in the resistance customer or business part or another load area. It is important to know how the power system support all the production until transmission and distributed the energy to the load center. Next one is now the renewable energy is become of the powerful resources in the nature, especially the growing fast of the technology in wind turbine and solar cell system with many type like currently innovation. It is important because the natural source from the from the wind and another type solar or another resources can include in the load side. Also, it can be applied on the generation system. So it means renewable energy has more potential to apply and integrate it to the power system. This is important how we think it can be applied and it can be spotted for our energy consumption. Next one, if we think about the system sufficing for delivering energy, so we think about the three main company. If we think the first point is power enterprise, all of the power plant will be managed in the enterprise to produce the energy from the various power plant, not only fossil based, but another for renewable also. After that, we also think about the second part or second company that relate to the transmission and distribution. We call that this is the TD operator, which is used to manage all of the networking in the power system. After that, we also at the final for the system, this is the energy user, not only depend on the characteristic or depend on the type of energy usage, but all of them we call as the customer. It means that all customers will use at the end front end of the energy user. So this is a three part if we think that energy as the business for the power transaction and energy bargaining. So we have think about the power enterprise or TD operator and then customer or energy user. Next one is also very important. If we think about how the energy will deliver to the load center or load area from the generating unit until it can be used at the final user. So we think that has three steps in this point. So we include one of the conversion from the natural resources. The first point, the energy conversion will convert the natural resources using mechanical process or another step. So it means the natural will energy in resources from natural will change to the mechanical energy. After that, from the generating unit, it means the energy, electric energy will generate it based on the electrical process or another process commonly with a magnetic process. After that, energy will transfer from the system with increasing voltage to the system to reduce the loss. So it means become to the transmission or transmission system. There are any energy, any power will be transferred to the load flow from the distribution system. With distribution system, there are many connected for for the like cable or another type topology to support the load bit integrated to the system. So it means we think how the energy delivered to the load center or energy user at the final or front end in the network. Next one is very important. Very important, like this less as we think about the daily operation. So there are any limitation for the time, like 24 hours, start from 0 to the 24 hours. It will cover for 7 days a week. So this is very important, how to manage and how to control and how to make a maneuvering a system to control the leveling of the transmission and distribution. After that, we also control and also manage at the energy user, because the energy user is depend on the behavior of the consumer, depend on their activities and their appliances. So we have to mix a combination between all of the power plant. In this case, the power plant, I mean a suitable power plant during the time for supporting all of the energy needing at the load demand. So this is very important. We know and we can control like what this both of them can mix balance in energy system. So after that, we have to think about how the performance to keep all of the energy in a good performance, not only in generating unit, also in transmission and distribution is also monitored to the load demand. It means some parameter we have to control and we have to manage and we have to monitor in order to it can be touched and maintained until this condition become continuously stability in the power structure and power delivery depend on the like voltage, current loss, and another technical requirement and technical performance. This is some indicator how the operating performance can attach and manage until the energy delivery to the demand give us some guarantee with a good quality for the energy consumption depend on the production and how the system will be applied from the technical requirement. Sometimes also the environment condition include inside. Next one is if we think the economic operation, it means depend on the how the energy production and energy consumption together measure depend on the cost of each other like that. So we think about the demand, a power plant, renewable plant as possible, and then after that, technical requirement also include on the system. After that, we also consider the environment penetration, because now some environment like emission or thermal heating is very important to consider in the system operation. After that, we also how the operating conditions should be maintained. So it means very important, not only depend on the infrastructure, but in economical aspect, we also think all of them depend on the cost or operating cost in totally about the system during for 24 hours in a week or 7 days. This is very important. How the energy can support demand and how energy can produce with suitable cost or like minimize cost is very important. So if think the energy cost as the pessimist, so at the first previous set, I introduced the 3 sections about aspect for the business like enterprise and then transmission charge. Enterprise is will have some rate for all of the generating unit during the production of the energy. After that, this energy will transfer for the transmission system and distribution. Now this network will organize, will manage, depend on the company. So maybe this company will make a charge for the transmission and distribution system during the energy flowing from the enterprise. So after that, at the user, at the customer of the energy. So there are also has some capability to buy the energy. So it means the energy will have several category like energy rates from the enterprise. After that, also energy will have a just possibility from the operator. After that, at the energy user, they will have energy price that they can select at the possible suitable or possible charge for the price which is selected from the enterprise and operator. Next one is this is the bargaining market possibility to discuss about energy enterprise and TD operator and energy user. So three sectors of the business in energy will make some discussion or some negotiable chance to select and to decide how the price possible for the customer and how the possible charge for the energy price and transmission and distribution operator. So this is the three-part section will discuss about the bargaining market to depend on the price. So the pricing system is very important. Like this, the price will be gradual from the base load, and then after that medium load until peak load. After that, we also maybe the price will be changed like a day load until night load. So depend on the characteristic of the pricing system. It's mean very important to make some combination which is suitable for the customer and enterprise. Also, it's mean it's also negotiable for the operator. This is very important thing about the energy business depend on the bargaining market. Next one, if we think about the transaction in energy, like a previous said, so it means we have three part, enterprise, operator, and customer, that they will discuss each other until they decide that suitable for energy market. So we think about this is the cost possibility for the rate, this is a possibility for the rate in enterprise, and then this is possibility rates for the operator as customer. So pricing in the energy selling and buying is depend on the negotiable for all of them, because they has a chance to manage energy production in the generating unit at the enterprises. After that, they also have a chance to apply some charge for the transmission network and distribution network during the operation for energy delivery. It means very important customer select, which is the suitable like cheaper energy from the production and cheaper energy from the transmission and distribution system. So this is the pricing system depend on the possibility for the customer, enterprise, and operator. So negotiate for each other is very important to keep and possible selection system or selected solution. Next one is this is the optimal concept. If we think the operation for the power put portion, it means during 24/7 the energy will support for the customer. So all of the operating should be managed and should be selected and distributed in the economic operation concept. It means we have to select with the minimum cost production. After that, it's also transferred in the system network with a suitable cost, such as not only minimum, but in technical requirement also support in this point. So the cost scenario is very important. How the enterprise include in the economic system. After that, how the customer rate also including in the economic operation. Also, how much demand, how many, how amount the power demand is mean. Also, we have to decide including in the cost scenario. So transmission and distribution also including in the system. After that, if some environment should be compensated, so we think about the possibility to include in the cost scenario. So all of them in this point, we have to manage depend on the various characteristics, various requirements, various limitations, include in the one of the cost scenario. So in this point, very important how economic operations should be approached in this system, because we have to think about how possibility cost for the generating unit, especially at the enterprise, access. So we also think about how the charge is possibility at the TD network with operator, other than how also the cost is possible for energy buying from the user. This is very important. So think about the possibility from all aspects of the enterprise operator and demand. One of the method to support the economic operation or dynamic based on the cost, so we can use not only on the classical method or approach, so we also can about from the evolutionary computational approach. Like now we think about the how the natural adoption. I will introduce in this meeting three parts. If we have to explore or development about the natural resources as the main idea for the computational method. So think about phenomena, behavior, and process. So we have three steps. After that, we can like some form or some structure to adopt this method. In this point, this is a characteristic on how one step can adopt to implement the natural resources or natural idea become the computation step. This behavior from the salmon behavior. So we have the first. We have two figure. The first is the left up to show that the salmon behavior from the pond to the sea, after that to sea from the pond. Another figure shows the obstacle and predator that face from the salmon during coming back to the pond. So this is the some behavior and some process at the salmon behavior. So in this slide, I will show how the procedure in this point. So I introduce about the first is migrating parts from the pond to the ocean. This is we have to downstream. After that, we have also upstream. So in this migrating approach, in this computation, so we have a model like this, ocean from the pond. So we have two behavior. One is exploring behavior. After that, surviving behavior. So this is the characteristic for computation in this slide, in this presentation. After that, this is the artificial salmon tracking algorithm called in ASTA, which is with two step, exploring step and surviving step. Now we think about how to apply this algorithm into pricing system or energy transaction. This model for the typically model for IEEE. So we have IEEE certified system divided to three areas. Areas 1 and areas 2 and areas 3. The red box one is the area 1 with a scenario to cover one generating unit. This means we have a scenario for the blackout if all of the system will getting off depend on the generator in the area 1. After that, the second area, we have some substitute generator or replace generator. It's meant for the backup model. Depend on the blue one for the area 3 is meant for the export and import characteristic in this presentation on this work depend on the energy transaction. Next one, this is the result how the export import transaction depend on the area and depend on the energy pricing in the area 1, area 2, and area 3, which is a cover for the energy price or energy rate at the enterprise or energy generating unit. After that, also cover for the TD operator in mean transmission and distribution operator rate. After that, also consider the customer rate. So how the energy will cover for the area 1 depend on the how daily load will be supplied from the enterprise at the area 1. Maybe another one if the enterprise is not enough for the all of the energy. So from the enterprise 2 and enterprise 3 will support for the area 1. Like now, this is very important for area 2 also. If the area 2 not enough enterprise, I mean, not enough for supply in all of the load in area 2, so they will import energy from the area 3 because the area 3 has a huge energy depend on the 3 generating unit of the enterprise. So it means for the energy stock and export import depend on the area 3. I mean, if the area 3 is the production is huge for the load, it means the energy will export to the area 1 and area 2, depend on the rate of the energy price at the energy rate at the enterprise. However, depend on the transmission and distribution rate from the operator. So it means all of the energy will transfer from the area 2. It will charge from the operator at the area 2. If the energy from the area 3 will transfer to the area 1, maybe the energy from the area 3 will be charged at the network for the operator at the area 1. So it means all of the transaction between enterprise and enterprise. So we can see this another bargaining selling of energy between enterprise and operator. So this is very important, how to control, how to make some limitation or some attachment during the power flow analysis. So this is because the transfer for the power not only depend on the area 1 and area 2 or area 2 and area 3 or area 3 and area 1, but the power flow will flow for the edge of the network in the system that both of the area integrated and the single system for the working. But inside of the area, each other has operator at its own enterprise. Okay, thank you very much for my presentation. Thank you for Prof. Sata to giving the time for the first presentation. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor, for your very remarkable, interesting, and informative plenary speech. Now we take this opportunity to open for the question and answer session to our first plenary speaker, Professor Effendi. A participant can write it at the comment bar. We'll try to assist reading the questions on behalf. If there is any questions, no questions. Okay, so if there's not any question, let me, I have a question, Prof. I can see a lot of efforts in terms of using renewable energies. Actually, my question is if energy efficiency retrofitting considered in residential buildings, I mean, and how much behavior of residents is important in energy efficiency retrofitting?
Yeah, okay. Thank you very much. That's good question for Prof. Satan. I mean, the front end of the energy user is in resurgent and another type of the load. We have many types of the demand, like not only in resident, like industrial, business, or plantation level, but the major energy user in many countries is in developing country. I mean, depend on the resurgent. So how they can tell or aware in energy using is very important. Like now, if the energy lighting, if the thing about the it is very important to use the lighting. So we have to switch on the light. After that, if we think about this is not important. So I think how to maintain, how to improve energy aware from the resident is very important. If we think about the culture, it's depend on self for the daily activity, but we have to adjust by a technology like use automatically switch off, depend on sense to the light and dark, like mean. So we force the behavior for the research and behavior based on the technology attachment, because it's very easier comparing to the behavior of human of ours. So if we put some technology in this behavior, I think behavior for the energy user will will change gradually, depend on the system. Like in-house, how we can manage the energy using, not only depend on switch on or the switching, but we also think about this is very important, no or not. But if we think about this depend on me, depend on us, because this is my house, this is your house, so all of this house depend me, depend ours.
Exactly.
It is difficult. So the attachment from technology and energy is very important to maintain the culture and the characteristic how the energy using a behavior in this point. Thank you,
Yes,
Dr.
exactly. Thank you for your answer. If there are no more any other questions, let us proceed to our second plenary speech. Let me introduce our second distinguished plenary speaker, Dr. Andrea Galli. Dr. Andrea got a degree in environmental engineering in 2001 at Politecnico di Milano on mathematical modeling of mechanical behavior of sand under cyclic loads. Then he attended the doctoral school at Politecnico di Milano, and he got a PhD in seismic and geotechnical engineering in 2005 on mechanical interaction between buried pipelines and landslides. Since 2007, he is assistant professor of soil mechanics at Politecnico di Milano. Now, without further ado, we proudly bring to you our honorable respected plenary speaker, Dr. Andrea Galli, to convey for his plenary speech. Please welcome Prof. Andrea. Again, 20 minutes time is all yours.
Okay, thank you. Thank you very much, Dr. Sattam, for inviting me and for introducing me. I quickly move to my presentation since the time is running. Just one moment that I share my screen. Okay. I hope that you should be able to see my screen, isn't it? Okay. So thank you very much. It's a big honor to be here as a plenary speaker, and I am very happy. But I was actually really frightened of the invitation by Dr. Iman Farshi because sustainability are relatively difficult issues. So I tried to introduce some basic concept of what a geotechnical engineer, as I am, can do with regard to sustainability issues in a built environment, with particular regards to what is my field of interest, which is soil structure interaction problem. Sustainability is a topic that is getting more and more interest in these last decades, because we are all aware that our resources are limited and they take long or very, very long time to recover. So if in the meanwhile, if we will waiting for a resource to recover, we could fall asleep or even worse. But there is another point that we like to stress, is the fact that we live in a complex system. So a small change in the governing condition of our system can induce an abrupt change in the state of the system. That is what mathematicians call catastrophic transition. And well, without recalling the well-known chaos theory, all of us is aware of the fact that, for example, small changes in the average temperature of the air can induce at the global scale, at the global planetary scale, even catastrophic events. So let me introduce some definitions, because actually the scientific community is speaking about sustainability since some decades, and I found this definition remounting at the early 80s as a sustainable system, as a system which is able to satisfy its own need without compromising the possibility for future generation to meet their own needs. So there is a sort of equity among people and equity among different generations, which is very important. When we speak about sustainability, we needed to balance among equity, environment, and economy issues. This is the general concept of sustainability. But since we live in a highly technological world, for sure engineering is a part of this process. So in many publications, you can find the definition of the 4 E's of sustainability as equity, economy, environment, and engineering. But how can we measure sustainability? Well, this is a very hard task because the search for a sustainable solution for design purposes is very often a wicked problem because the system is ill-formulated. We have confusing information with many clients and conflicting values. This definition is taken from Buchanan's 1992. If we separate to each one of these keywords, we can easily recognize the fact that we live in a complex environment. We very often work in a framework of lack of information with multiple stakeholders and multi-objective function. So it is very difficult to find a unique optimum solution. And even the use of quantitative metrics based on scalar indexes like the carbon footprint or the global warming potential, as well as the use of indicator system that try to take into account different aspects of the same problem, well, can only work as tools to compare different design solutions, but according to me, they can hardly provide a unique, well-defined solution. So what is my definition of sustainability for our design actions in a built environment? Well, I will introduce a very few mathematics, so I hope not to bore you. Let's consider that we live in a system whose state can be described by a formal function f, which depends on 2 sets of variables. A set alpha of natural variables, that is the variables which are not under the control of the designer. Let's consider, for example, the global temperature of the air, or the rainfall intensity, or earthquake actions, if we want to refer to earthquake mitigation risk. And then there is another set of variables which is under the directly control of the designer. These are the so-called anthropic variable. And this is exactly our design variable. Our design choices refer to how can we modify this variable beta in order to build our project. Then the third set of parameters, set K, which is related to the size of the system, because of course, when we speak about sustainability of a single building is different with respect to sustainability of an entire region, if we want, for example, to design an infrastructural transportation system. Both alpha and beta vary with time. So, in my opinion, sustainability means that the system does not change with time, or at least does not change that much. So we can introduce the concept of an allowable consumption rate as a small quantity epsilon that is a threshold for possible variation in the state of the system. If we mathematically develop this expression, we can put in evidence some partial derivatives, but my goal is to put in evidence that we can define a criterion for defining our design choices. So how we can change the anthropic variables beta during the design process. Because if we consider the present state at time t0 and the current asset beta 0 of the built environment at the present state, these 2 limitations allow us to define a possible fan of sustainable choices, you see? So we can decide whether our design actions, I plot here, for example, 4 design actions, A, B, C, and D, are sustainable or not. And it is very interesting in this case to observe that, for example, actions A and B, which are the same design actions, but implemented with a different rapidity may or may not be sustainable, depending exactly on the installation rapidity. Or other actions like C and D are not sustainable. And please observe that action C is the so-called doing nothing option, because we do not introduce any variation in the built environment. But even typical decommissioning actions could be not sustainable if not properly designed. But beyond this very simple discussion, my goal is to put in evidence that for matching sustainability criteria, we have to combine different aspects, because each one of these four terms that appear in these two inequalities has an important meaning. For example, the first one, the effect of the natural variables on the system, is basically the domain of natural sciences, or more in general, social sciences, as well as the effect of the anthropic variables on the system, so the effect of our design decision on the system, is related to technological, scientific, and engineering skills. The variation of the anthropic variables is basically representing our design choices, so exactly what we are looking for. And finally, the fourth term is the variation on the environmental variables in time. And of course, it is related to monitoring effects. So my goal here is to put in evidence that in order to match sustainability criteria, we need to adopt a deep multidisciplinary approach, combining scientific skills, engineering skills, with other field of research. And even more important, we need to have a continuous monitoring of our system, because we live in a changing environment. So where is geotech? Why, even in geotechnics, we need to introduce sustainability issues? Well, because geotechnical work usually involve very, very large volume of soils, and they are usually intended as permanent, or at least nearly permanent work. If you need a bridge, if you build a dam or an embankment, of course, it is almost a permanent work. And in literature, there are many examples of possible topic of intervention for sustainable geotechnical engineering, possible reuse of foundation, the use of underground space, the mitigation of geohazard. But and of course, the earlier we are involved in the design process, the higher is the potential for taking sustainable decisions. So if we are involved since the very beginning, from the planning phase, we can, for example, discuss about the better positioning of our construction, or even to philosophically think whether it is better to build or not to build our structure. It's again a decision, it's an anthropic decision. But later and later on, we are involved in the project. Of course, we have a progressive reduction in the potential effect of taking sustainable decision. As I told you at the beginning, I always work in soil structure interaction problem, and so I will focus my attention on the sustainability issues related to the behavior of structure, because it has been pointed out in the scientific literature that in order to match sustainability criteria, geostructures should be designed with an attention to performance criteria rather than only to the ease of construction or economics of construction. They must be designed with regard to site-specific considerations. And of course, soil structure interaction need to be a fundamental aspect to be taken into consideration. Why soil structure interaction is so important? Well, just a brief review. Soil structure interaction is a real multi-scale approach. Our structure interact with the surrounding soil, and we usually have defined a lot of different numerical approach to describe the interaction of our structure with our soil. For example, we can use a finite element or finite difference method in order to describe the interaction at the micro scale of the structure. But we need to start our description from the study at the local scale of the representative elementary volume by defining a constitutive rule at that level, or even go in further details at the micro scale of the grains by using distinct element method, for example. But we can even enlarge a bit our overview, since the macro scale of the structure is very often interacting with a mega scale of an entire environment, for example, a slope where the structure is built. So, of course, we have numerical tools capable of study each one of this scale, but putting together all this scale is a very, very difficult task, even from a computational point of view. So the idea is to introduce a new approach that can help in upscaling a bit the problem. And this concept was proposed 30, 40 years ago by the concept of the macro element. By using the macro element approach, we can describe the behavior, for example, of the foundation of our structure by upscaling the law from the local scale of the representative elementary soil volume to a macro scale of the entire structure. And the advantage is very important because at the macro scale, we only need very few number of degrees of freedom. So we can reduce the numerical dimension of our problem to a very reduced number of degrees of freedom. So we can gain much advantage in numerical efficiency. In particular, the original concept of macro element was proposed by Professor Roberto Nova and Lorella Montrasio in late 80s. And for a shallow foundation, they define, for example, a comprehensive failure condition represented by this sort of surface in the loading space. I just changed the point. So this balloon surface represents a comprehensive description of all the possible failure mechanisms, not only the failure mechanism referring to the vertical sinking of the foundation, but even the failure mechanism considering the possible horizontal sliding or rocking of the foundation. I want to go into such details, but since there, the macro concepts were largely developed by researchers, taking into account more and more general geometries and more general constitutive rules. So nowadays, macro element concept can be used for solving a technical problem. And in order to show this aspect, I would like to discuss with you at least 3 case studies. I hope to have time, otherwise, please, I ask the chairman to stop me. In particular, I'll start with one case study referring the town where I live, Lecco, which is 50 kilometers north of Milano. Years ago, we were charged by the municipality of Lecco to study a bridge, the Azzoni Visconti Bridge, who is the most ancient masonry structure that we have in Lecco. It was built in the 14th century. It is a bridge 132 meters long, and for many centuries, it has been the only bridge, is in this position, you see, connecting the two rivers, the two sides, of the river. It is always recognized as a very famous bridge because it is a part of the landscape of the famous Mona Lisa portraits. Very proud that even Leonardo da Vinci was inspired by this bridge. From a technical point of view, we recognize that in 1949-1950, the bridge was subject to important strengthening intervention. In particular, the original foundation of the pier, which was a direct foundation of the masonry pier, was reinforced by the introduction of a sheet pile, a circular sheet pile, 5 meter depth, connected with the original pier by means of a reinforced concrete ring in order to get a continuous foundation. We were charged by the municipality of Lecco of making a diagnosis of the bridge, and in particular to verify its seismic behavior. And I was charged of the geotechnical campaign, so I prescribed the realization of different geognostic survey, and I managed to characterize the soil constituting the riverbed and so the foundation systems. Our goal was to perform some numerical analysis referring to the seismic of the bridge. And I modeled the behavior of this foundation by using the concept of the macro. It was in particular interesting to compare the behavior that we get for the present foundation, behavior that we would had for the original foundation in order to check the efficacy of the strengthening works. And by comparing this result, it was quite evident that the original foundation was characterized by a vertical factor of safety of about 2, whilst the strengthening intervention has much increased the vertical bearing capacity, so they have largely improved the vertical resistance of the system. But for what the horizontal behavior is consistent, we observe that the obliquity of the load is basically the same both in the original and the present foundation. And similarly, the horizontal safety factor is basically unchanged. So if we remind our conceptual framework, this example would stress the fact that the use of an improved interaction model, because to study the soil structure interaction problem, would have allowed at that time to improve the design of the strengthening intervention. A second example that I would like to discuss with you refers to the protection of an infrastructure, a railway infrastructure, from a potential risk deriving from landslide activation. And this is, again, the site of interest is in this position, 40 kilometers from Lecco and 30 kilometers from Milano. Refers to the railway, which was built on a steep slope, 40 to 42 degrees of inclination, about 15 meters high. And this railway was affected by slow superficial soil movement. The original proposed intervention by a designer was to build a continuous sheet pile or even a retaining wall, a gravity retaining wall, 15 meter 8 and anchored below. But we tried to adopt an alternative design based on a deep preliminary monitoring of the system. So we were able to monitor the weather variables, rainfall events, and the temperature changes, for example. And by means of summing, we were able to define even the displacement field observed slope. And by adapting the monitored displacement field and an original interaction model to describe the interaction between the landslide and the piles, we were able to largely optimize the design of these piles, because our final result was to propose piles with only about 6 meter length and anchored with pretensioning action. It was always also possible to optimize the pretensioning effect by correctly mixing the active pretensioning action with the long-term passive behavior, so that we can optimize the behavior of the structure not only with respect to the immediate response of the system, because we were able to immediately reduce the profile of displacement rate of the soil, but even the long-term response of the system by checking that, for example, after 50 years, the displacement rate of the slope were below a given threshold, and that the internal action in the pile do not reach the critical value corresponding to the yielding of the pile. If I still have, this is clearly an example that points out the importance of the monitoring system to get sustainable design choices. If I still have 1 minute, I can finally present the problem, which is basically the object of my PhD thesis, of interaction between pipeline and landslides. Because in my thesis, I have generalized the approach of the macro element for shallow foundation to the case of pipeline. And I have tried to apply this model to a real case study of quite a long pipeline, 1,600 meters. It was a steel pipe, 75 centimeter diameter, and subjected to an important displacement profile of soil of about 12 centimeter in approximately 6 years of monitoring. we were able to validate our approach of the macro element with respect to some submit taken during the chosen time window. And we were even able to use this model due to its high computational efficiency to perform a lot of parametrical analysis capable not only to describe and working condition of the system, but even to foresee the long-term behavior by amplifying artificially the imposed solid displacement profile, thus modeling future possible states. And so it was possible even to define not only factor of safety as a ratio between the yielding condition of the steel and the current state of stress, but even a factor of safety as the allowance of displacement of the soil with respect to the current amplitude of soil displacement. So this will allow us to have even a safety time window within which we can design our intervention. And so this is my final slide, because in this third example, I think that the point is the combination between a good technological and scientific skills that allow to perform efficient numerical analysis and a correct monitoring of the environmental actions. So we can not only decide which is the best possible sustainable decision, but even to foresee the future possible evolution and to define a sort of sustainable path for future design choices. So what is the conclusion? Actually, I don't have a conclusion, but I simply want to point out three things: that sustainability for construction environment is taking care of our system, taking responsibility of what we do, and always looking to the future, because we must provide this intergenerational equity. We cannot consume all the resources for future generation. Thank you very much for your attention.
Thank you, Dr. Andrea Galli, for his very remarkable, interesting, and informative plenary speech. Now we take this opportunity to open for question and answer session. Very fast, because we have time limitation at the moment. Is there any question from the comment bar? I think there is no question from there. So
of course, if you want two questions.
Yeah, there is two questions.
To collect question and send me by email, I will happy to reply even by email, so no problem.
For sure. At the moment, I can see two questions. Is macro elements can be applied to flexible foundations or only rigid foundations? And positive to use sustainable solutions such as soil rooting traction?
Oh yeah, they are both very interesting topics. Just two quick replies. Of course, macro element can be used only for flexible structure. And the case of pipeline, for example, is exactly a case of very flexible structure. So it is possible. There is a second level reply, because you can take into account flexibility into the macro element as an internal parameter. So even at the local level of a single foundation, you can calibrate your macro element in order to take into account the flexibility of the foundation. For the root-soil interaction, of course, this is a very interesting topic, and there is a lot of literature, scientific literature to this topic. Roots have an important effect on the stability of the slope. They usually gain strength to the slope, and they could represent a sustainable and an environmental friendly solution. But again, sustainability, it's not only a matter of being green, because sustainability means even technological skills to be used in order to implement that solution. So again, please be very careful when you decide to adopt some solution, because you always have to balance even a technological skill. It's a multidisciplinary approach, as I try to discuss in my speech.
Great, thank you for your answer. I can see two more questions from Dr. Shinto Amiri. I missed the first one on his screen, but the second one Okay, the first one. Thank you, Prof. Galli, for your amazing presentation. I have two questions. One, in your opinion, how geohazards induced by anthropic activities of geoconstruction?
So how our activities can, for example, trigger a landslide? This is the question. Well, of course, it is a consequence. When we play with our anthropic variable, we can induce a change in the system. So again, we always be aware of the fact that each of design choice that we can take has a consequence. This is taking responsibilities. This is my last slide.
Great. And the second question, can I see the second question on the screen? Yeah. And how to prevent these hazards from leading to catastrophic failures?
Well, it depends on the scale of the problem. For example, if we work at the planetary scale, the example of the climate change, of course, it is very difficult. We only have to progressively reduce, for example, the CO2 use in order to mitigate the climate change. If we look on a small scale, for example, a slope stability scale, or at the scale of an infrastructure, if we are interested in building an infrastructure, again, we have to classify the possible risks. If it is a geotechnical risk, a structural risk, a social risk, because each action that we adopt has even a social impact. And then once you have classified this risk, you can look for the most appropriate mitigation measure.
Thank you very much. Thank you for the answers. Thank you.
You're welcome.
All right. Participants, ladies and gentlemen, on behalf of the conference organizing committee, we would like to thank the Honorable Professor Dr. Afendi and Dr. Andrea Galli for the plenary speech, the Honorable Vice Chancellor, Director of Research, Innovation and Postgraduate Studies, and Conference Chairman for the opening remarks, panelists for technical seminar, all the session chairs, invited guests, participants, and all of you in the audience. We are very much honored to have all of you today. Thank you. Some important announcements. We will proceed with the parallel session presentation sharp after this opening ceremony. You may miss your presentation slide if you are not in the room on time or as per schedule for your time. There are 3 parallel sessions which will be held concurrently as session A, B, and C. Please proceed to enroll to your respective Google Meet session room. However, you may switch to other room to listen for other presentations at any time up to your liking. Please use the provided Google Meet address available in your conference invitation email. Our technical seminar will be started sharp 4:30 p.m. and this session, we have different ID. It will be online. Guest StreamYard link session 2, I think it's on the screen right now. You can use this link for the technical session. And certificate of presentation will be sent to presenter and participants latest by next week. Please be informed. The conference survey will be conducted later after event. The organizing committee will email the link to all of you, and please do cooperate to respond for further improvement. Ladies and gentlemen, now we have come to end of our opening ceremony and plenary session. On behalf of the organizing committee, I would like to extend our sincere appreciation to everyone who involved in this conference, either directly or indirectly. We hope everyone had a good time with us, and we wish you all happy conferencing. Thank you again for supporting our virtual event. Good evening. May peace and prosperity be upon us all. Thank you. See you again in parallel session, technical seminar, and closing ceremony. Thank you so much.